My name is Oren Golan, and I from Los Angeles. I came here for about 2 weeks, and I'm going to talk about graph databases. So it's supposed to be a workshop, which I'm not sure if it means that it's going to be like hands-on with laptops. So I kind of like gauge how you guys want to do it, and we'll decide as we go whether we want to actually do some coding or maybe stay in a little bit higher level. So we'll see. So that's about it. I'm hoping that you're here because you want to learn about graph databases, or you just want to get socks of Adventure Time. So I'm not sure who's here for the socks, who's here for the graphs. Raise your hand, socks. Okay, I got two people that honest. That's good. So I hope it's for both. If you don't know what Adventure Time is, it's a pretty famous, maybe one of the most popular TV shows in the US, which means that it will go to Singapore very soon, right? What's the timeline usually? A few months ahead, or maybe a year? I don't know. So we'll see. So in terms of the format, I mean, you guys can feel free to ask questions while I'm talking. I think I like this chaotic kind of style of conversation, and if I see it getting too chaotic, I'll change my ways. But feel free to ask whatever and interrupt me in the middle. Let's make it more conversation kind of a thing, as opposed to just like me talking and you guys are quiet, and I think more fun. So I work in Los Angeles in a company that we're helping big farmers to go quicker to the market when it comes to their clinical trial process. So we're doing the patient recruitment piece, which is getting the patient to the clinical trial, and we're also taking care of the logistics and building a platform for managing the whole logistics of handling clinical trials. That's some of us with candies flying above. That's our office. As I mentioned, we have some swag, so just to keep you guys awake. So I'm going to ask some fun questions, and whoever answers get a stock. And actually, there's 2 T-shirts as well. So fun times. So please give me feedback. So I'm going to share my email and my website, which is actually oren.github.io, and there's links on the right side to everything, LinkedIn or whatever. Give you my email. So I need feedback. I want to get better at presenting and the way I give talks. And I have a very, very thick skin. I gave a talk called AngularJS is Dead about a year ago. It was an AngularJS meetup in LA. Right. It was like 9 p.m.-ish, and people were so passionate. I was almost got stoned at the end. I was so embarrassed that I didn't want to publish I didn't want to share the YouTube video. I just put it there and kind of like secretly, never blogged about it or anything. And then my coworker, hey Oren, a few months ago, hey, your YouTube has like 20,000 views. I'm like, no, it doesn't make sense. I never did anything. And then they told me, hey, why don't you enable comments for the lols? So I was called a dipshit. Therefore, I have a very thick skin. So I can tolerate anything. So be honest and tell me, how do you think it went? Yeah. So yeah, it's a good thing. Just put a video that is going to be annoying for go to we have like an Elm meetup very soon. I'm going to give a first talk. Going to be called JavaScript is Dead. I really think that Elm is taking over. Do something like this. Put it on YouTube. It will make you tougher. So that's our agenda, and I'll try to stick to it. I'm going to talk about the use case for graph database. What are the advantages of using a graph database? The third item is kind of like an overview of the main graph databases that I and my team did research on, the dominant player in the market. All of them are open source. I'll give you the differences. And then we're going to play, or at least demo, Neo4j, which is the most popular one. And the last section, which hopefully I have enough time to actually demo, another graph database that I'm really passionate about called Cayley, open source. I have one fan here. You deserve a sock. Do you like Finn or Jake? The dog or the guy?
I don't care.
You don't care?
I take both.
Oh. So yeah, Cayley lover. So Cayley is interesting. It's written in Go, unlike most of the databases that are written in Java. I personally prefer to use Go now than other languages for server-side stuff. I'll talk about it later. It's pretty awesome, but I wanted to see other alternative and then make your own decision. So what are the use cases for graph databases? Anybody know what is this inside? It's this is like the different packages. What is it? Yeah.
glibc.
Yes. Unbelievable. You already got a stock. So I don't know what to do. I'm going to ignore you. So it's glibc. So that's the most dependent package in Ubuntu, and I assume Debian. So you can map this stuff with a graph. You can anything to do with logistics. This specifically is flight patterns around the world. If you have like a reservation system or hotels or even like e-commerce stuff, and you want to know where the item goes, right? It's a flow and different station of the item stayed in. And actually, Amazon CTO recently wrote a blog post about how they use TitanDB with DynamoDB for exactly that. They have a few billion nodes and edges that they're storing. We have new people here. Hi guys.
Hey.
You missed a sock. Don't worry. There's a few more. Another usage is Internet of Things. So think about different devices, and let's say you have a refrigerator that needs to access to a drone that needs to do a delivery for you, and this delivery, the connection between the fridge and the drone should be available with specific permissions only when the drone actually has the package. When you drop the package, you don't need to have any connection with the drone anymore, right? So all these permissions, you can map it into a graph, right? So it's actually a very good use case for Internet of Things. And there are companies, there is a startup in Germany that I can't talk about because the guys on IRC chat told me not to talk about it, so I'm not going to mention his name, but they're doing exactly that with Internet of Things, and I think they have like maybe 30 billion nodes right now in their graph, or they're going to have it very soon. Fraud detection, banks, finance industry, it's easier to detect fraud. So if you have a transaction, somebody purchased something in McDonald's, and then there's another purchase in McDonald's, and the pattern of the second purchase is very different, you can use graph algorithms to detect it. So it's very good. It's a classic use case for graphs. And the last one is our body. So biology has a lot of graphs in different organisms and in nature and also in our body. So if you think about the cancer cells and the mutations in your body, you can map them into a graph to understand how where they're going. That's the same idea. And our brain is actually a graph. If you think about it, it's the biggest, more complex maybe graph out there. So graphs are everywhere. So okay, fine. I convinced you. Let's say that graphs are everywhere, but how is it applicable to us as software engineers, people who build products, right? That's what we care about. We need to make money. We need to empower our users, and so on. Anybody knows what's the name of this dog? Crickets. All right, that's Jake. That's one of the main characters of Adventure Time. Anybody want a sock of the dog? I'll just throw it. So they have very good relationship. They're best buddies. So if you have a lot of relationship in your domain, whatever domain it is, probably it's good to use graphs as opposed to use relational database. Because relational database is not great at relationships. It sounds weird because it says relation in the name, but it's not. I mean, and I'll explain why later on. But when you have a lot of relationships, that's where graphs can be a good candidate. Another advantage is that it's very friendly. You can literally go with the entire team, you and the product people and the people who are not technical, and actually have a nice little design of the graphs and the nodes and the edges, right? Think about this as a vertex, and this one is an edge, or a node and a relationship, right? And you can just map them on a whiteboard, and product people can understand it, unlike tables that are a little more complex and not very intuitive to understand, even sometimes for us. So I think that's kind of like getting together product people with the engineers. It's a good example, and we're actually using it at my company, and I already noticed it, that the people who are not engineers can talk our language now and speak our lingo. That's a not very funny joke, but SQL query walks into a bar and sits to a table. He walks up to them and says, "Can I join?" And that's a problem with relational databases. you have a lot of joins. And this stuff, I took it from a free book about Neo4j database. And you can see the differences when you have a friend of a friend. So this is the depth number 2. Find a friend of a friend in a RDBMS, which is a relational database, compared to a graph. It's pretty much the same, but look how the degradation is almost exponential. And eventually it's going to be almost, you won't be able to even wait. It's going to be too much time to wait for a graph, for a relational database, and it will still be pretty fast, 2 seconds to find a friend of a friend of a friend of a friend of a friend in a graph. So if you have complex queries, they're probably going to be better to use it on a graph, because joins are just costly in terms of the time that it takes. If you have too many joins, I mean, yeah, you can have 2 joins, 3 joins, but then it's getting a little tougher. That's a very important aspect, which is how much does it cost you in terms of time and money to make a change? And reality change, technology change, the requirements change. If you need to make, for example, Ice King liked to kidnap princesses, and he had a crush on Princess Bubblegum. That's your reality. You want to map it into a table. So you're probably going to do something like this. You're going to have a table with a few characters, right? So Ice King, and then you know if he has crushes, and you can have a crush on a person, number 2. That's pretty cool. That's how you're going to do it with graphs. So you're basically going to have a node, a relationship, and there's a direction, and you have another node. And I'll explain later exactly how to do it, but that's conceptually how you're going to do it. Now, what happens if your reality change? Uh-oh, you didn't think about it. You didn't think that one person can have 2 crushes, because you design your system in such a way that it only have 1. So what do? You need to start introducing on another table, maybe move around foreign keys, add some primary keys, and you do something like this, maybe. And then maybe you have another changes, and maybe eventually you need to have many-to-many. So you need to introduce another table for the many-to-many, right? It costs money, you need a database administrator. If you work for a big company, it's pretty costly. How do you do it with the graph? Anybody knows? Who answered the first? You already got one. The guy with the pink shirt. So that's it. You just add another relationship and another node, right? That's it. So it's kind of like the agile approach for data in a way, because you don't need to define the schema ahead of time. You just create it on the fly as the need comes. Of course, you need to make sure in your application level you have different constraints, unless the database has constraints, and some databases do have like types and stuff. But yeah, it's very, very flexible. This piece is like, you know, we have 2 different teams in a company. You have QA, and you have everybody poop on each other, basically, right? What I see in my company, that we have this more collaborative approach, and there's no like, oh, I'm a DBA. It's like we're all together. Yes, some people they like data, so they're going to be your DBA guys. But it's everybody kind of like understand it. Everybody work in a collaborative aspect, and I think that's kind of part of the whole lean and agile, right? If you reduce the handoff to another team, if you can contain everything within your team, you're going to execute faster. That's the bottom line I see here in the handoff. So it's a 10:15 LA time. Still have 45 minutes. Great. I'm going to talk about the different graph databases that I was looking at, and kind of like tell you a little bit about each one. Kind of like help you make informed decision, or help you like in your research, so you have a good starting point. So basically, what it is, this is just from Wikipedia, a database that uses graph structure for semantic queries with nodes, edges, and properties to represent and store data. So that's what it is. And if you start doing your research, you will find probably Neo4j, because they have a very sleek marketing machine behind them. You might find TitanDB, which also pretty popular, maybe the second after Neo. And you might or might not find about Cayley, because Cayley is a newish one, and it doesn't have the marketing power behind it, but it has a very, very passionate community. There's a few more. There's ArangoDB, I believe, which has some interesting hybrid between MongoDB and graph database, so you can store documents but also have graph. I didn't have a good impression from the leadership there, and it doesn't seem to be very good. If you look at your GitHub, the way that they're handling their issues, and I wouldn't touch it at this moment, but I would look into those three. Obviously, there's way more than this. There's an older guys, non-open source that you can look into. I did not do any further exploration, but so Neo4j, the first commit to the Neo4j was in 2002. It's written in Java. The type of the graph is a property graph. There's a few types of graphs. There's property graphs, and there's something called RDF, or a triple store, which I'll talk about it later. So for now, let's move on, and I'll explain in a few minutes. There's no pluggable backend. Basically, Neo4j, it's a query and it's a database in one package. And I'll explain what it means pluggable in a few minutes. The way to query Neo4j is to use Cypher or Gremlin. So Cypher is something, is a query language that is specific for Neo4j. That's also the problem, because if you learn Cypher, you're probably only going to use it with Neo4j. So it's not very portable. Gremlin, on the other hand, is an attempt to build something which is more portable between graph databases. Maybe I'll see if the link here works, and I have internet. I'll show you what Cypher looks pretty interesting. It's kind of like an ASCII art, so the way you write it. So this is a good example. So you have A like B, right? So you actually literally know these like parentheses, right? You put whatever you want inside, and this one is for the relationship, and you put likes inside, right, into B. So that's a simple relationship. You see match node, return. See if there's anything interesting here. So that's basically how Gremlin looks like. You can read about this on the Neo4j website. They have pretty good documentation. Gremlin, on the other end, looks like the Neo guys don't really support, or they don't encourage you to use Gremlin, because they're trying to push everything to use Cypher. But I think it's a pretty good idea to actually learn Gremlin, because I think it will something that will pay off later on when you're going to move to maybe other graph databases. It's also called used to be called Tinkerpop. Don't ask me why the name Tinkerpop. They're a great animator, or great designer that just look a little bit of. I want to show you the queries, how it looks like. So here it's another great, but yeah, G.V is like a graph dot vertices, basically. I guess show you all the vertices in our graph, all the nodes, right? And then I can say, show me all the nodes that have values name in it, or the name. Show me the name. Sorry, show me the value name, so it will show you this markup. And then out E is show me the edges that are going outside. The direction is outside of a node. So that's how you do it. You kind of chain together whatever you want to from a graph. And it's getting more and more complex, and you can read all about it here. That's how I'm adding vertices. So it's pretty.
Yeah. Can you query for any properties on the edges themselves?
Yes. Yeah. You can do like show me all the people that are age of 32, right? Specific properties, and you can do like between, 30 to 40 and so on. Yeah.
So doing this in a relational database, there will be a table, right? And doing this will be easy. But how do you locate the edges? So if, say, I want to find all the people that have crushes in your example.
Yeah, I'll show it. I'll show it later on. Good question, though. Yeah.
Can you give like a specific value for a crush? How strong the crush is?
Yeah, you can have depending on what graph you use. Neo4j has can have key values, not just on the node itself, but also on the relationship. So yeah, so you can have like the time that the crush happened until from until where. Let's say you have systems like in our case, we need to have be HIPAA compliant. HIPAA is the regulatory for medical industry in the US. I'm sure there's an equivalent in Singapore. We need to keep trace and log and audits of everything that happened. If there's a Ice King has a crush on Bubblegum, but tomorrow he has a crush on another princess, we need to keep it somewhere. So yeah, we have all kinds of techniques. We call it a flower, that we keep a node, Unix time, on the edge that tells you like, oh, at 2015, whatever month and date, you will have a crush on bubblegum, and before in 2014, you had a crush on somebody else, right? So you can kind of keep it, and you can move around. You can say, I want only the current, but if the auditor comes and wants to see what happened, what changed, you can go and query the edges that are not current. So there's different ways to play with it. So yeah, that's Gremlin. So the license, so if you want to use Neo4j, you can use the community edition right now, download it, install it. It's great, it's works, it has a nice UI, which I might demo if we have time. The problem is that as soon as you want to productionize this stuff, you want it highly available, you want hot backups, incremental backup and stuff. That's where you need to pay, and you need to pay a lot of money, depending on how you negotiate with the new guys. It's a Swedish company that have headquarters in San Mateo. They have consulting services. They can go and come to you. They're coming to us and helping us with consulting, but it costs money. And it's AGPL 3, the Enterprise Edition. And the Enterprise Edition has everything you need for production. You have highly available setup of like 3 or even more nodes or cluster of 3 with a nice automatic failover. If the master is down within 20 seconds, there's a new master to be elected. What you would expect from highly available distributed system. But it costs money, and the license is kind of interesting. So you got to be aware of it. The community is pretty good. They have books, you have events, you have training, they have IRC, and they have also Slack channels, so you can check it out. And I like this metric at the end, the time to first hello world. Whenever I evaluate any especially open source products or any product, right? How long did it take to go to hello world? And I would guess it can be 10 minutes. Just reading some stuff, installing Java, and depend how some people if you already have Java installed or not, and so on. TitanDB, it's a little newer. It's 2012, also in Java. It's also property graph. Property graph means that you can have key values not only on the nodes, but also on the edges. You have this key value concept basically that you can apply on nodes and edges. An interesting property of this guy, interesting characteristic, is the pluggable backend. So you can use Cassandra as your backend, you can use BerkeleyDB, or even recently, a few months ago, Amazon announced that DynamoDB, which is their key value store on their AWS cloud, you can use it as a backend. And I tried, it wasn't very trivial to set up the DynamoDB stuff. That's why I wrote here, it can be a few hours to set up a Titan. It's not as polished in terms of like the documentation and everything. But it's working and it can scale. If you have the time or the people that can go and dive into it or already know it, or maybe you bring consultants and they offer consulting. The company, I can't remember the name actually, did I write it down? Yeah, Aurelius used to be the bunch of very smart PhDs behind it, and they got acquired by data stacks. And those guys provide services, and they can help you with this stuff if you don't have the expertise, because it requires some expertise. And if you guys have ever managed Cassandra, you probably know that it's not a trivial task to optimize and make sure it works. So, community size is decent. It's not as good as Neo4j, but still a pretty good community. They're not very big on IRC chat, and IRC, which makes me a little sad inside, but maybe it's something to do with the Java community. I don't know. I'm not part of the Java community, so I'm not sure. But they have like an online forum and stuff. This is my favorite right now, Cayley. It's very recent, 2014. It's written in Go, which I really like. It's very, very lightweight in that aspect. And I actually didn't bring with me the Raspberry Pi, but you can. I tried it and it's pretty cool. You can put it on small little devices and it just works. This one is an RDF or a triple store, which is a little different. So it's not. You only have. You can't have properties basically on edges on the nodes, and I'll show you later on how to deal with this stuff. Also has pluggable backends, so you can use if you want. You can use on one machine only. But let's say you have enough hard drive. Let's say you have whatever 20 gig. You can put 130 million. It's called a quad, which is two nodes in a relationship on a 20 gig hard drive. You don't even need highly available system. Why to make it complex, right? So you can use LevelDB or even Vault, which is very, very fast. It's key value written in Go, embedded database within the process of your server. It lives. But if you do want a more robust system, you can use something like MongoDB or Postgres, and Cassandra is coming. I saw some PRs about Cassandra, and people are talking about Scylla, which is a Cassandra equivalent, just like way faster. So they're coming. There's a bunch of PRs that are waiting to get reviewed and stuff. So query language is very similar to Gremlin. It's kind of like it's JavaScript actually. It's a JavaScript interpreter that is written in Go. It's separate dependencies that Cayley uses. It looks like a Gremlin, but it's in JavaScript, which is pretty nice. License is Apache 2, it's free obviously. And the interesting part is who created this stuff. It's a guy that used to work for Google, and now he works for CoreOS, and actually CoreOS are using it, using Cayley. Are you guys familiar with CoreOS, by the way? Anybody? So CoreOS is an operating system that you usually use. Kubernetes, for example, the whole Docker. It's optimized for running Docker. It's a very interesting company, very smart guys, and they're using it internally. So what happened with this guy? He worked on a product called the Freebase, and Freebase was a huge knowledge graph. Google acquired them, I believe in 2010 or 2012, I can remember. And then he was working on the knowledge graph team at Google. So when you make say hello Google now, give me the pizza next to Clarky, that's something like Cayley is actually operated behind the scenes. He left Google, and now he kind of like took the core of this graph database and open source some pieces of it, and that's Cayley. So it's not just him; it's a bunch of people, smart guys, and we have a pretty small community on IRC. We also have a Slack channel, we have a Google group, and it's called Cayley on Freenode. That's what I'm using usually, or Slack. So pretty friendly community, but small. But I'm kind of like happy that I'm talking about this stuff because I want this community to grow, and hopefully you guys, or some of you guys, will join and ask questions and participate. So. And that's nice. The time to finish Hello World is like literally a minute. It's like just download the Go executable and that's it. You're good. Any questions so far? Or we're good? Okay.
I have one.
Yep.
So for all the graph databases that you've shown, you can store values on the edges. Is it possible to create like relationship between specific edges, like meta edges? Just curious.
Talking about kind of like information about a node, or about the entire relationship?
Yeah, more about like information about the specific relationship.
Mm-hmm. Yeah. So you can do it, different approach to do it depending on the database. When I talk about Cayley, I'll show you what Cayley give you in order to do it. It's a piece of information you can point on a quad. A quad is like two nodes and an edge, basically. If you're talking about a property graph like Neo4j or Titan, you would probably, if that's the case, you would probably, instead of using two nodes and an edge between them, just replace the edge with another node. That's how it seems like. Because if you have something that needs to be, somebody needs to connect to, it's probably more proper to be a node itself. It's more important than just an edge. So yeah, that's how you do it.
So it seems like in a graph database there would be some storage overhead compared to, because we're creating node for every entity. So right, there's a new pointer for every. Is that the case?
I don't know if you're going to be stored over. If you think about relational database, sometimes you have tables that like you don't even use, some of the columns in them. So it's a good question. I don't know for sure. Like if there's I know that Cayley, for example, it's about can store about 130 million quads, which have two nodes and an edge, for about 20 gig hard drive. But they're improving it actually right now. There's databases that can store way more than this. Obviously, and yeah, if you look at Postgres, it can store way more in Postgres and more optimized. So I'd assume that you might be right, that in good, robust database that exists for 30 years in the market probably has better storage. But that's not really the problem. You're going to use a graph database because you have a graph-like or relationship in your, But yeah, it's a good question to ask. I'm not sure exactly the details though. Okay. So I'll show you Neo4j. I actually recorded a video. I gave a talk a few months ago in Toronto about actually about Docker, but I was so excited about graph databases, so I gave like a few minutes and talked about graph databases. I looked at before going to Toronto, I looked at Twitter, and I found an interesting tweet. So these guys are recently nominated Prime Minister of Canada, Justin Trudeau, and he looks pretty good. And there's a lot of people that wants to move to Canada from the US just because it looks good. And there's other people who are standing in the line to vote, and they hear some Canadian ladies that says that they want to vote for him and they want to move to the US. So there's an interesting exchange of like people going to move from place to place because of this guy. And also he hates puppies according to somebody. So I decided to like map it into a graph. Let's see if you have internet here. Free open source. If you need on more than one instance, you need to pay Neo. But if just one instance and you don't have the highly available feature or the clustering feature, you can get it for free. Just download it and run it. Bin Neo4j start. It's based on Java. And yeah, that's the web interface. You don't have to use it, but it's pretty convenient. It uses the Cypher query language, which is mainly in Neo. There's no other database that uses Cypher, so at least not for now. But it's a pretty convenient language. It looks like an ASCII art. I just created a bunch of nodes and edges, and I want to now display the entire graph. So I'm going to run this command: match n return n. So this is our graph. So you can see here I have Justin, and I can see that Chrissy is in love with Justin, and I can see that Sarah is also in love with Justin, and I can see that Justin bans puppies and he hates blue jays, and he's in love with Sophie, and so on. And that's pretty nice. You can see that there's nice colors here. I can actually change the size. Let's say it's all the people here, persons. I'm going to make them a little bigger. Yeah, now let's see what kind of queries I can run. Let's see who is in love with Justin, right? So I'm going to copy this here. So I'm doing a match p, right? This is an edge. Basically, show me all the nodes, right, that has this edge going out into another node that the name is Justin. So it will show me all the nodes that have are in love with Justin, basically. Yeah, show me Sarah and Christy, and if you see here, both Christy and Sarah are in love, and there's nobody else that is in love. Justin himself is in love with
right.
Sophie, but
performance
unfortunately she's not in love with him.
Maybe it's the HTTP API that you want to do the embedded approach,
she is,
right?
but not on our graph.
To troubleshoot it yourself and to do your measurements. I'm sure it exists on
benchmarks available.
I'm sure I can Google for it, but I haven't looked recently. Neo4j comes with a nice way. Every query you make, you can put, I think, profile at the beginning or some keywords before your query, and then it will give you a nice visualization of profiling Neo4j. Okay. So it will give you a drill down exactly of what is the query and what is the problem with your query. Here's an example for tuning your query. See the keyword profile? So match Tom Hanks. It tells you here how many rows it has to fetch and every step in the query. So yeah, you can read this piece. It's pretty cool. It's an interesting thing about Neo, you can actually run this stuff. Let's see if my browser will actually show something. Yeah, okay, nothing happened. But yeah, there's all kind of interesting features that you can do within a browser, actually do some queries without even having Neo4j installed. There's another question over there? Yeah.
2 questions. you know, when they kind of estimate how many quadrilles, whatever it is that they can save, surely you have to know the size of the object you're saving as well. I mean, if the object's got 50 properties, that will impact, or they're just working that out as some kind of assumption of average object size that they're going to be saving. And then the second question is, can you specify how many, if you're doing a, like a breadth, doing a search, how many levels deep must you go in the graph before you stop and all that?
Can you read the first question?
No, you know, you're giving estimates of the storage size, and you're saying on 20 gigs they can store.
Oh, that's for Cayley, yeah.
Yeah. I mean, surely you need to know the object, the size of the object you're storing. So the
Yeah.
Well, I just don't know if I'm misunderstanding something.
Yeah, you're right. I don't know the exact. It's on the Cayley's README actually. So take a look and you can drill down to see the exact. I don't know if they elaborate. It's a good question. Exactly, as you say, it can be a giant string, right? Yeah, I don't know exactly how much was it. But at the end of the day, you know, it's very cheap to add have a little bigger hardware. But yeah, that's a valid concern. I don't know. Yeah. And what was the second question?
You know, how many levels deep do you go in the graph? And what happens if you've got a circular or the acyclical graphs, or you just end up in a loop?
Yeah, I mean, I don't know. I mean, something that you need to profile, you know, to see. It depends on your graph, depends on the complexity of the shape of your graph, you know. Some graphs are very, very flat, you know, and some are deep or even like cyclical. So yeah, it's hard to answer. Just, you know, you just need to profile everything, just like you do with any other database, right, or application. You just profile it. Yeah.
How difficult is it to move an existing database to one of these, or is it easier to just put a GraphQL server on top of your existing database?
That's a great question because we're actually doing exactly that. So, there's no like one answer for this, obviously. So it depends on how does your data look like, right? It's not that complex. You basically need to write some, and also I guess another question is, do you need to have like, can you just do it overnight? You know, if you can do it like within a few hours and you're done, then it's easy. But sometimes if you have a huge amount of data, then you need to pump it like slowly. So it all depends. But you basically write some kind of a script, right? That then make, you know, REST endpoint make calls to your endpoint to the new database and populate it. The tricky part is the modeling aspect, because it's a different way to think of your world. You need to think of objects and nodes and instead of tables. So it's a little bit of a shift in the mindset. That's the main thing, how to model this stuff. But you can read, there's a ton of information online, depending on what database you choose, you know, and you have community that people can help you, and they already did it. That's the main thing. It's not really technical. It's mainly like, just like I mentioned, the whole flower arrangement to keep like audit trail. It's not trivial, you know, and there's more than one way to do it, right? So if you need to like, and you need to add something to your system, you need to like remove some nodes maybe and add some nodes before, so you can have like some sort of functions in your language, programming language, helper functions that do it for you. So the next developer that comes doesn't need to know all the intricacies of the relationship. It's call your function that will take care of, like, you know, adding a new crush to a character on Adventue Time, right? And it will take care of removing the old crush, or maybe put the Unix timestamp on it and connect the right node. So you do a little help function basically to abstract away the database. Yeah.
I'm interested in knowing if it's possible to create a kind of complexity that you create, like an algorithm that tries to find a pattern graph.
Yes, that's a great question. I didn't mention it. So the question was, is it possible to use graph algorithms, right? And the answer is yes, and that's why graphs are awesome. So you can, I say you can, sometimes some graphs like Neo4j and also Gremlin has a built-in function. So let's say Dijkstra, or, you know, finding the shortest path to somewhere. All the computer science problems that are in graphs are now, or some of those algorithms are built in the database that you use. So yeah, and for example, in our case, we use to take the Uber approach. So we're sending our, so we need to match between a nurse and patients. Cancer patients, we want to match the closest one, so you can apply all kind of like geospatial algorithms that will give you like all the drivers around a passenger very quickly. It's perfect for graphs.
Within one or a few queries?
Yeah. Probably 1 line. It's already. This comes from Gremlin and Neo. You can do it in one function. They literally have shorter span function, I think. Pretty cool. Yeah. Let's talk about Cayley. I think we'll have time to show some code, even though this resolution is awful. It's like the oldest monitor in the building, I think. But if you remember the example before, right? So we have Ice King, and he has 2 crushes, right? That's how I do it in Cayley. You basically write a file. It's called a quad file. That's an RDS terminology. It's called a quad file, and you have a subject, predicate, and an object, right? That's what you have. And you have Ice King, and you put here, because there's spaces, you have to put quotes, and then you put an ID. In this case, I wrote character colon, right? And then I wrote, for instance, bubblegum, but this can be a UID in your system, right? It doesn't have to be, as long as it's unique. And even though each of those guys, and by the way, there's also a dot at the end. That's kind of back to your question about meta information, right? So this is a quad. It has 4 pieces. This is also the last piece. This is the last item in the quad. And right now it has nothing in it, but you can put information that would be a meta information about this quad, about these 3 nodes. I haven't used it, and I need to read about this stuff because it's something that they're actually doing right now, and they're modifying and making it easy to use, but it's there for the meta information. But for now, I'm ignoring it. I'm just using the object, predicate, and subject, predicate, and object. So yeah, so you're gonna have a file, and you're gonna have, if you want to load your database, simple file, and then you just one command, load, and I'll show it to you.
What's the meaning of character there? Like, is there a class?
Which one?
Character.
The type of method.
Oh, this guy?
Yeah.
Oh, this is supposed to be a unique ID in your.
The whole thing.
Yes.
Oh.
So I just did, for me, user friendly. Like I'm gonna put character colon. But let's say I'm gonna have, medicine. You have a bunch of medicines. You have a medicine colon and then the name
So
of medicine, or a human being, human. Just like a name for yourself.
Is defined by the developer or is generated from by
Developer,
the
yes, you define it.
Okay.
So you can replace the whole thing with a UID. But then it's not going to be human friendly, so I prefer to use character and then the UID. So in the real world, yeah, I would do character and then here, it's kind of like a slug, right? It's like a URL, so it's the same idea, but you can have like a UID here.
Would you normally model your nodes with types? Or do you have like different types of nodes
Yeah.
in your database?
Yeah, I like to, in Cayley, I like to do this stuff. I like to have like a, and I show you, I say Ice King, character Ice King, type, king, or human, or whatever, Jake, dot. Yes, and then you can then query only, because the thing is that you want to query not the entire graph. It's not going to be performant. You want to query a subset of the graph, so you can query only those who are type human, right? So that's how, even though your graph can be a billion and billions of nodes, right? As long as you start your query with a subset which is pretty narrow, you're good, So yeah, that's it. That's how you write it down, and find everyone that Ice King has a crush on, right? So what I'm doing here, I'm saying G.V is like finding everything. I don't want to find everything. I want to find only the node that has character Ice King. And so this is like the first part is kind of like where to start your query from. And the second part is like the whole like query itself, right? So, or what edges I want to go to. I want to go to the arrows that goes out of the king and they have his crush on them, right? So all of those arrows. And at the end I can do all or only one. There's a few options at the end, the last function. And then I can see that both Marceline and Prince Bubblegum. So basically, he has a crush on both. So basically, I'm using a program called Dot. Anybody heard about Dot? You did? So basically, I'm using Dot. So basically, you can feed Dot with like a bunch of like lines and the relationship, and it will create a graph for you just to visualize it. And you can also define like how much thickness, and you can see that they do a great job, especially not on this monitor. But that's the entire graph database that I want to load into Cayley. So it's all the characters and a different relationship between them, who hates who, who's his crush, has a crush on who. And this is the type that you think you asked about. So I want the dog Jake to have a type of dog, right? So that's a type. You see here type. Who is this? Bimo. Bimo is the little video game character, and he's a type of Bimo.
So for properties, you also use nodes to actually set the properties, or it's two different kind of things?
Exactly. I don't have I don't have properties in an RDF graph. So everything is a node. It's very simple. But it can be a little verbose, right? So that's where your helper functions come into play. Because after you do it once, you don't want to do it again. So you write a little helper function that's abstract the verbosity from. So I think I want to show you guys how to load. Can you see, by the way, the screen, or maybe this one is bigger, right? So here, first thing I'm going to do is installing Cayley. Cayley is a graph database, open source, written in Go. It's very interesting. It's very, very fast. It was written by, or the lead developer used to work for a company that was acquired by Google, and then now the same sort of graph is being used when you make a search on Google Now. It's using graph databases, which is very similar to this one. The nice thing about Cayley is that you can replace the backend, so you can use BoltDB, which is very fast, or LevelDB, Mongo, even Postgres, even though it's not documented, and I think Cassandra is coming too. So you can start with embedded. Basically, you can embed it within the process, which is very fast, using Bolt. And then if you see that you need stuff like high availability or clustering, then you can switch to Postgres or maybe Cassandra in the future, and slowly scale with your needs. I'm going to show you the REST interface that comes with the Cayley. First command, first thing, there's a config file where I can define where my database is, what's the backend, where it is. In this case, it's Bolt, which is a single file, just temp Canada. And I'm going to run this command, which is the init, to initialize the database pretty fast. And I'm going to load a file that have already a bunch of edges and nodes. It's a little different than Neo4j or TitanDB or other databases. It only has doesn't have key values on edges or nodes. So basically, what you see here is it's called a quad, because there's 4 elements here. First is the person Sophie is an ID. The second one is the edge. In this case, it's a type, and the third one is the node, or it's called the object. So this one is the subject, this one is also called the predicate, and the last one is the object. Basically, it's 2 nodes and an edge. The last one is, I'm not using it, I'm not sure exactly what to do it. It's called the label. I'm just using the three first elements here. And you can see them defining Sophie person and Justin. And I said that Justin, he bans puppies, and I have Chrissy here, Sarah and Tyler, a bunch of people, and the relationship between them. So I already loaded it, and now I'm going to run the HTTP interface. I could run the REPL, but just for the sake of the demo. And let's see the website. It comes with it. Okay, hello world. Let's run some query. Let's see who is in love with someone. Anybody that is in love in our graph. Okay, see that Justin, Sarah is in love with Justin here. Chrissy and Justin himself is in love with his wife Sophie. Now it's I didn't mention it, but it's something very the query language is very, very similar to Gremlin, which is pretty nice for those who like Gremlin, and that's the most popular query language for graph databases. This is interesting. You can see that you can use JavaScript here. Basically, it's JavaScript syntax, right? and I'm just assigning two variables. So I want to know who loves Justin, live in the US, and move to Canada. And eventually I can just run it one time. And I see that Chrissy is the only one who's has everything that I need to. It's an end or an intersection. Yeah, that's about it. And there's also a way to visualize it, similar to Neo, not as fancy, but it's pretty cool. Let's go to the query that we wanted to run here to see everyone that iSking has a crush on. Punch it into, and this is literally JavaScript, and you can see you can have variables inside. You can do everything from the REST endpoint, or if you embed it, I don't have time, but I have an embedded version. I have a repo on GitHub shows how to do an embedded approach. Run query, boom, okay? And I can put this in a variable. I can do stuff like foobar, remove the all, right? And then do something with foobar. Like I can say here, this is like in love with, crushes, right? And here I can say hate. Maybe he hates and has crushes, and I can do something like crushes and hate all. Right, so I can do stuff like this, intersection and stuff. It's all documented pretty nicely. Let's do this. Let's do.
Is it easy as a kid?
Let's see if this one works. Yeah, I guess it's giving me the same result.
So the object that you're getting back is like an iterator, and if you're calling
Yeah.
all like
Yes, exactly.
So you can do stuff like paging, whatever you need.
Yeah. Yep. This one, find everyone that have a crush on Princess Bubblegum, right? So I say, start with Princess Bubblegum, and show me all the edges that pointing toward her. That's what it says in, right? And has crush on. Let's just run it. See. Go here. Okay. So you see both iSking and Finn, Finn is the kid, they both had a crush on Princess Bubblegum. Okay, that's another query. Anybody that has a hates toward him. I'm showing this is tagging. I can tag. So basically here, the result is like, you can see that so Lumpy Space Princess and Bimo, they all have hates in them. I guess the tag lets me, when I traverse on the graph, I can tag in the middle, right? So in here I want to tag who is the person who hates. Because here, you can see that Lumpy Space hates somebody, but you don't know who she hates. So if you want to like also like kind of like tag somewhere in the middle of the query, you can say, okay, tag the person, and put in as a name. So it shows you that Lumpy Space Princess hates iSking. Basically everybody hates iSking. I want to show you the last one, the last query. All the haters that lives with Bimo, right? It's a little more complex, right? So I can say, first give me all the haters. Then give me everybody that lives with Bimo, and then show me the intersection between them, right? And you'll see that there's only two, Finn and Jake. So somebody hates Finn, somebody hates Jake, and they also live with Bimo. I didn't have time, and I didn't even bring my Raspberry Pi, but it's super tiny. Cayley, you can put it anywhere you want. There's a demo that I did a while ago, and you can find it and play with it and just play it. There's different links how to like help and just join the community. Bunch of videos, they're pretty good. And that's my email. That's the slides. Feel free to shoot me an email, connect with me, and keep in touch and ask questions. Or that's it. Thank you. And yeah, tweet about this talk, said it's the best talk at the conference.
You were not at the today.
Deep shit, yeah.
Yeah, but you were not today.